Welcome to our presentation on the automated moderator, a Bluesky labeler designed for assignment 3. Our project team include Wenzu Ma, Jessica Chi, Omer Moav, and Dimple Retod. We will now walk you through our technical approach and evaluation results, focusing on targeted financial harms on Bluesky. Our policy focuses exclusively on two concrete forms of financial fraud. First, airdrop wallet connect scams, post promising free tokens or NFTs, pushing users to connect crypto wallets. Second, paid to join insider signal scam, post selling VIP trending signals with unrealistic profit claim and off-platform payments. Decentralized platforms like Bluesky are prime targets for financially motivated malicious actors, causing immediate and often irreversible harm. This activity degrades content quality and erodes user confidence. Our labeler enhances user safety by providing granular risk warnings, specifically targeting scams like Wallet Connect and insider signals without resorting to centralized censorship. We designed a multi-stage detection pipeline to balance large-scale coverage with accurate, context-aware judgment. Stage 1, keyword-based high recall filter. We normalize the post text and scan it against created keyword groups for both scam types. This gives us broad coverage and ensures potentially risk posts aren't missed early. Stage 2, deterministic heuristic rules. These rules look for multi-signal scam patterns such as airdrop claims paired with wallet connect terms or invested signals paired with off-platform payment language. If neither stage 1 nor stage 2 triggers, the pipeline stops immediately and produces no labels, since the post shows no meaningful indicators of harm. Stage 3, LLM-based scoring. For posts that trigger earlier stages, we send them to DeepSeek v3.1 model, which outputs a probability that the post belongs to one of our two financial scam categories. We apply a threshold of 0.7. Any post exceeding that probability is converted into a final policy label. Together, these stages gives us a pipeline that is fast, selective, and conservative, catching likely scams while avoiding unnecessary labeling. Our evaluation relied on a dataset of 242 unique posts, gathered using key phrases and manually labeled into three classes: scam, potentially scam, and safe. To ensure robust data for the difficult edge cases, any potentially scam label required 100% consensus among our 4 team members, ensuring rigorous annotation methodology.
And efficiency was our primary design driver, directly addressing the cost disparity. We measure latency across stages. On stage 1 and 2, latency for initial interception is extremely fast, averaging just 3.5 milliseconds. On stage 3, latency for the external LLM API call is significantly slower, averaging 1.2 seconds per post. Our short-circuit architecture minimizing the frequency of the costly 1.2-second call, preserving overall efficiency. Before establishing the final filter, we first conducted rigorous testing to optimize our keyword selection. We gathered posts using key phrases like contact wallet and VIP signal, and manually labeled them into 3 classes, which is scam, potentially scam, and safe. We then derived automated keyword lists using both the frequent list and the scam keywords minus safe keywords differential list. The initial filter performance was assessed using 2 methods, which is frequency limit and top N. We finally chose the top N method for its more stable performance in achieving high recall, which was essential for minimizing false negatives. The remaining stage focused on maximizing precision from the ambiguous post flagged by stage 1. On stage 2, initial LLM prompting showed limited returns, while V2 achieved a high precision rate of 97.4% for data 6. The overall F1 score was 87.7%. It suggests inconsistency in the edge cases. So we think that simple prompting and hard-code rules lack the contextual adaptability it's needed to handle for the diverse and evolving scheme. So to address this, we moved to stage 3. It was necessary for reliable cross-scenario performance. We utilize structured output and rigorous threshold analysis. For wallet schemes, the best result shows high precision at 88.1% at threshold 0.8. For insider signals, the best operating points span from threshold 0.1 to 0.7. So considering the need for a stable operating point, so that we chose threshold 0.7 as the primary threshold for our final pipeline. At this point, the system demonstrated strong overall performance for 92.2% of precision and yielded only 9 false positives against 106 true positives. And on the successful execution of the DeepSeek v3.1 model, this strategy enforced structured JSON output and validated our hypothesis. high precision with strong recall is feasible. It justifies a multi-tiered labeling strategy. Our next step focuses on scalability. One is for data augmentation. It is required to prevent model drift. The second one is model optimization. It will explore fine-tuning a smaller open source LM to reduce the computational cost associated with the API calls. Yeah.
We will now be discussing about the ethical implications of our solutions. Our labeling solution targets a very narrow and well-defined harm category. And the ethical considerations relevant to our system arise directly from the technical architecture of stages 1 to 3 and our policy boundaries and the empirical test outcomes. Because stage 1 is intentionally high recall of 95 to 96%, benign posts may trigger it, and that may lead to legitimate discussions of signals, generic DeFi conversations, or harmless wallet-related terminology. And overlabeling could stigmatize normal crypto activity or falsely associate users with fraud. But our solution mitigates this. How it does it is it uses in stage 3, when we use DeepSeek version 3, it prioritizes precision up to 96.1% for insider signals and 88.1% for wallet scams, substantially reducing false alarms. Threshold 0.7 ensures only content with strong contextual cues is labeled, and our labels are informational, not punitive, and avoid user-level judgments. Given the financial stakes, underlabeling can also expose users to immediate harm, especially for schemes where we try to identify wallet connect, gas-free drains. The design choices that we've used in our solution, we minimize it. We minimize this risk. We're minimizing the risk for that. How we do this is in stage 1, we have top-end differential keyword strategy, which achieves around 96% recall across scam types. And in stage 2, we use heuristics, which capture high-risk behaviors, which are not reliant on vocabulary alone. And the multi-stage pipeline ensures harmful posts are almost always escalated to stage 3. Now we talk about the ethical considerations related to the transparency and the LLM use. We balance our transparency with exploitability. High-level policy categories are public, but exact technical triggers are kept private to prevent evasion, where users could try to understand what are the keywords used, and they could try to evade those and misuse it. Ethically, LLMs also act only when after deterministic signals, and stage 3 uses probability scores and not definitive statements to account for misinterpretation. Now we talk about mislabeling risk. Finally, we are acknowledging the predictable mislabeling risk due to inherent ambiguities. This includes misclassifying legitimate trading advice or urgent aids as scams, but a high final precision remains our strongest defense against these ambiguities and linguistic nuances. And that brings us to the end of the ethical risks that would be associated with our solutions. But all of these mislabeling risks stem from the fact that humans have constructed these keyword lists and annotated the data set, and therefore the system reflects human blind spots, ambiguity, and cultural assumptions. Now we'll be moving on to the demo of our solution. Okay, I think that.
Yeah, so here is our submission folder. In this folder, there are a lot of files. I'll lead you to go through it. So first, this is the policy proposal labeler. This is the core Python file. It has the policy proposal labeler class, and it has all the analysis logic and the role classification, also with the LLM API call, large language model API call. And the next file is the evaluate policy proposal labeler. So this file, it can get a CSV in and do everything and call the policy proposal labeler as well, and output the scores and also the results in the CSV. And here is the data.csv file. In this file, we can see that there are about 240 data, and these are all real data from the Bluesky. And also, we got the classification set. There are 2 files which will be used by the policy proposal labeler to process the data. And here, I'm now going to run the evaluate policy proposal labeler and to show you guys the process. And you can see here is the Python code I run in the terminal. Yes, and it is now moderating the post. Yes, so what we did is we used a funnel design. So first, we will load the classifier set, and to classify all the data, we will see that whether these data has matched the keywords. If it has matched the keywords, it has the probability to go through. It has the probability to be the harm data, and it will go through the pipeline. If it doesn't match any of these kind of data, it will just be marked as non-harm. And after that, we use the heuristic to make the first classification. And from this, we use a regular expression to match whether the data has this kind of sentences. If it has, we'll highlight it and we'll give both the data and the highlight sentence to the large language model for it to give us the scores, like the probability of the data to be harmful. If the data do not have any of the regular expression matched, then we will just give the data to the large language model instead of having the highlighted sentences. Yeah, so after all of these, the large language model will give us a probability, and we have set a threshold for 0.7. So it means if the probability is larger than the 0.7, it will be the harmful data, and it will mark as harmful. If it is less than 0.7, it will be the non-harm data, and then it will be marked as safe. Yeah, after a while of running, we can see that there are the text file output for the scores, and the precision is 93%, and also the F1 score is 83%, and also there is the CSV output, which we can see here. So I open the output for CSV, and here it goes. You can see that here is the predict labels, and also it even can predict what scam it is instead of just giving you out the label. Yeah, here it goes. It is really clear. Yeah, nice. And this is our code part.